Welcome to another deep dive, everybody. Today, we're going to be looking at the adapter design pattern.
Very interesting.
Yeah, it's all about making different parts of your software work together.
Right.
Even if they weren't, really designed to initially. So
Yeah.
kind of like a universal translator for your code.
I like that.
We've got two sources today for this deep dive. We've got an article from Refactoring Guru
Okay.
and a YouTube video that, breaks it down visually.
Cool. Yeah.
So, in the Refactoring Guru article, they use this analogy
Okay.
of a laptop charger.
Oh, yeah.
Like if you're traveling to Europe from the U.S.,
You're right.
your charger won't fit in those outlets.
You need an adapter.
Exactly. You need an adapter.
Yeah.
And it's the same idea with this design pattern.
Right.
But instead of physical plugs, we're talking about the interfaces.
Yeah, the interfaces in your code.
Exactly.
And how sometimes they just don't match up.
Right. And that's a pain.
Yeah, definitely a pain.
So the article really lays out the problem well. Imagine you've got a chunk of code that needs to work with another piece of code.
Gotcha.
Maybe it's a library or something.
Right.
But their interfaces clash. They just don't work together.
They're like speaking different languages.
Totally. Like they're speaking different languages. They can't understand each other.
And that's, it's something that happens all the time.
Right.
In real world development.
Yeah.
Like, think about if you're working on a project where you've got to integrate a legacy system with a new one. Or you're trying to use a third-party library that wasn't designed to work with your code.
Yeah.
You constantly run into incompatible interfaces.
That's a challenge, yeah.
The challenge.
So how does this pattern actually solve that?
Well,
Does it write a whole new language for them to communicate in?
not exactly. It's more like creating a translator
Okay.
that sits between the two pieces of code and smooths out the differences in their interfaces.
Okay, so they can actually communicate.
Yeah, like a diplomatic envoy.
Gotcha.
Helping them to understand each other.
Okay, so are there different ways to build these translators?
There are two main approaches.
Okay.
The object adapter and the class adapter.
Ooh, fancy. What's the difference?
Well, the object adapter uses composition.
Okay.
So,
Composition.
yeah, imagine it like building a car.
Okay.
You've got the engine,
Yeah.
the transmission, the wheels.
Right.
They're all separate components,
Uh-huh.
but they work together to make the car function.
They got to work together, yeah.
So in the object adapter,
Yeah.
the adapter contains an instance of the object it's adapting.
So it's like it's holding the thing it needs to translate for.
Precisely.
Okay.
And it exposes a new interface that's compatible with your code.
Gotcha. Okay, I think I'm starting to get it.
Good.
But what about the class adapter?
So the class adapter,
How was that one different?
that one leverages inheritance,
Okay.
which can be a little tricky to grasp if you're not familiar with object-oriented programming.
Yeah.
But think about it like a family tree.
Okay.
Children inherit traits from their parents, right?
Yes.
So in the class adapter,
Yeah.
the adapter inherits from both the class it's adapting and the interface that your code expects.
Wait, so it's like inheriting traits from two different families.
It becomes a hybrid, bridging the gap between the two.
Okay.
It can be a little chaotic.
Yeah, this sounds complicated.
It is, which is
Right.
why the class adapter is
Yeah.
only possible in certain programming languages that support multiple inheritance,
Okay.
like C++.
Gotcha. So it's a bit more specialized
Exactly.
than the object adapter.
And oftentimes, the choice between the two depends on your programming language
Yeah.
and the specific situation you're dealing with.
That makes sense. Now, I remember in that YouTube video, they had this really cool example
Oh, yeah.
using a video game.
Yeah, I love that one.
I thought it was I was like, ooh, this is a good way to illustrate it. They were talking about designing a game, right?
Yeah.
And they had this interface called enemy attacker.
Right.
And all the enemies in the game, orcs, goblins, whatever, they all followed this interface.
Uh-huh.
They all had methods for attacking, moving, whatever.
Right.
And then they wanted to add this giant robot enemy.
Right.
But it didn't fit that enemy attacker mold at all.
It did not.
Like it had lasers and rockets and moved in a totally different way.
Exactly.
So that's where the adapter came in.
Yeah, they created an enemy robot adapter
Right.
that implemented the enemy attacker interface, even though the robot itself didn't.
Right.
Inside the adapter, they stored an instance of the robot.
Gotcha.
So whenever the game called a method on the enemy attacker interface, like attack or move,
Yeah.
the adapter translated that call into the appropriate actions for the robot.
So the game was basically tricked into thinking
Yeah.
this robot was just another enemy,
Mm-hmm.
even though under the hood
Totally different.
is completely different.
Yeah.
It's pretty slick.
It is, and that's the elegance of the adapter pattern.
Yeah.
It lets you integrate these components that weren't originally designed to work together without having to rewrite a ton of code.
That sounds like a huge time saver.
Yeah.
I'm already starting to see how this could be really useful in my own work.
I bet. But before we get too carried away, it's important to understand both the advantages and the potential drawbacks.
Okay, so what are the pros? What makes this pattern so great?
Well, it simplifies your code by separating concerns. You're not cluttering your main code base with all this logic for adapting different components.
Gotcha.
Plus, it makes your code more flexible and easier to maintain in the long run.
Right. That sounds great, but I'm guessing there's a flip side to this, right?
There is.
Okay.
While the adapter pattern can be incredibly useful, it can also add complexity in some cases.
Okay.
Sometimes it might be simpler to just modify the code you're trying to use directly,
rather
than introducing an adapter layer.
So it's not a magic bullet for every situation.
Precisely.
Gotcha.
It's important to weigh the pros and cons and choose the approach that makes the most sense for your specific project.
It's like any tool in your toolbox, you wouldn't use a hammer to screw in a light bulb.
Yeah,
right?
Exactly.
Got to pick the right tool for the job.
And understanding when to use the adapter pattern is just as important as knowing how to implement it.
That's a great point. So it's not just about, memorizing code snippets.
Yeah.
It's about recognizing situations where this pattern can really shine.
Exactly.
But, I'm curious. The Refactoring Guru article also mentions this example with square pegs and round holes.
Ah, yes. Classic analogy for the adapter pattern.
What's that all about?
So imagine you have a board with round holes.
Okay.
And you're trying to fit square pegs into them.
They're not going to fit.
Obviously, they won't fit directly.
Yeah.
But with an adapter, let's say a small square piece with a round hole in the middle.
Okay.
You can make those square pegs fit snugly into the round holes.
Oh, I see. So the adapter is that bridge, right?
The adapter acts as a bridge.
Between those two incompatible shapes.
Exactly.
Okay, so in the software world, what would those square pegs and round holes represent?
Think of the square pegs as the interface of the component you want to use.
Okay.
And the round holes as the interface that your code expects.
Gotcha.
The adapter is that little piece in the middle that makes them fit together.
Okay, I think I'm finally starting to wrap my head around this whole adapter thing.
Good.
So we've talked about the problem it solves, the different types of adapters, even some real-world examples.
Yeah.
I'm still wondering, how does this apply to me,
You're right.
the listener? Yeah. Like, when would I actually need to use this in my own work?
That's a great question. And it's one we'll delve into even further in the next part of our deep dive.
Okay. Now you've got me hooked. Can't wait to hear more. But for now, I think we've covered a lot of ground. Time for a little break. We'll be back in a few minutes to explore some specific scenarios where this adapter pattern can really be a lifesaver.
Looking forward to it. So before the break, you were getting curious about how you might actually use the adapter pattern.
Yeah, like it sounds great in theory.
Right.
But I'm having trouble thinking of real situations where I would actually need to use it.
Yeah, I get it. It's one thing to understand the concept, but it's another to see how it actually plays out.
Yeah.
Let's say you're working on a project.
Okay.
And you need to pull data from a bunch of different sources.
Okay.
Like a social media API, a database, a cloud storage service.
Yeah, that could get messy.
They probably all have their own ways of formatting that data and sending it.
Right.
So instead of writing custom code to handle each one separately, you could use the adapter pattern to create a unified interface for accessing the data.
Gotcha.
No matter where it's coming from. Each adapter would handle the specific quirks of its data source.
Right.
And then your main code could just interact with them all through this consistent interface.
Ooh, like creating a universal data connector.
Exactly. Now, let's say you're working with a legacy system.
Okay.
And it's using some outdated logging library, but you want to switch to
a newer one,
a newer, more efficient logging system.
Right.
But replacing that old library directly would just require rewriting a ton of code.
Ugh, that sounds like a nightmare.
It can be a real pain.
Yeah.
But with the adapter pattern, you could just create an adapter that wraps the old logging library and exposes an interface that's compatible with the new one.
So it's like the adapter's this bridge between the old and the new.
Exactly. That way you can gradually migrate to the new system without having to refactor everything all at once.
That's pretty cool. That's really practical.
It is.
So is the adapter pattern only for really technical stuff like this?
That's a great question.
Yeah.
You might be surprised by the answer.
Okay.
The core concept behind the adapter pattern, this idea of like bridging differences to make things communicate,
Right.
it actually has applications way beyond just coding.
Oh, really? Okay, give me an example.
Think about project management.
Okay.
You often have team members with different skill sets and working styles, communication preferences, trying to get everyone to coordinate effectively.
Yeah.
Can feel a bit like trying to fit those square pegs into round holes, you know?
Yeah, I've been there.
A good project manager can kind of act as an adapter, facilitating communication and collaboration between those different team members.
Right.
They might translate like technical jargon into plain language for non-technical folks. Or maybe they're helping to bridge cultural differences between team members from different backgrounds.
Wow, I never thought of it that way.
Yeah.
So, like, the project manager is kind of like a human adapter.
In a way.
Yeah.
It's a good analogy.
They help smooth out the rough edges and make sure everyone's on the same page.
I like that. Okay, so let's go back to software development for a second.
Sure.
We talked about the good things, the pros.
Yeah.
About using the adapter pattern. You mentioned some downsides, too.
I did.
What should I watch out for?
So it's important to remember that no design pattern is a silver bullet.
Right.
One potential drawback is that the adapter pattern can add complexity.
Okay.
Especially if you're dealing with, like, a ton of adapters.
Right. Too many adapters could get kind of confusing.
Exactly. And sometimes it might actually be simpler to just modify the code directly.
Right.
Rather than introducing this extra layer of abstraction with an adapter.
So it's all about finding that balance between flexibility and simplicity.
Precisely.
Okay.
You got to weigh the benefits
of using the adapter pattern against that potential cost of increased complexity.
Yeah.
And the best choice is really going to depend on the context of your project.
I'm starting to get it, but are there like any specific signs that scream use the adapter pattern?
That's a great question.
Yeah.
One major clue is if you've got 2 or more classes with incompatible interfaces, but you need them to work together.
Right.
Another one is if you're dealing with a third-party library that just doesn't quite fit into your existing code base.
Gotcha. Those are some good guidelines.
Yeah.
Now, let's say I'm convinced. I'm like, yes, adapter pattern, this is the right tool for me. What are the best practices?
So first, it's really important to define that interface that your adapter is going to expose.
Right.
That interface needs to be compatible with the code that's using the adapter.
Okay, gotcha.
Then, within the adapter, you need to map the methods of that interface
to the corresponding methods of the class you're adapting.
So it's like you're making a translation dictionary.
Yeah.
Between those 2 interfaces.
Exactly. And remember, the goal is to keep the adapter as simple as possible. You just want it to focus on translating between those 2 interfaces.
I'm starting to feel like I could actually implement this.
Good.
But I think I still need to see some code.
Yeah.
To really get it. You know what I mean?
I hear you. In the final part of our deep dive, we'll walk through some actual code snippets. And see how the adapter pattern really comes to life in different programming languages.
Awesome. I'm looking forward to that. But before we move on, I want to go back to something you said earlier about the adapter pattern outside of software development.
Yes.
Can you give me another example?
Sure. Think about language translation.
Okay.
You know, when people who speak different languages want to communicate.
They often need a translator to bridge the gap. That translator is essentially acting as an adapter, converting those messages from one language to another.
It's like they're taking the interface of one language and adapting it to the interface of another.
Exactly.
That's a great example.
And this concept of adaptation, it's really fundamental to how we interact with the world. We're constantly adapting to different environments, different cultures, different ways of thinking.
Wow, you're right.
Yeah.
The adapter pattern's starting to feel less like a coding trick and more like a fundamental principle of how we navigate the world.
It's a beautiful insight.
And it's one we'll explore further in the next part of our deep dive.
Yes.
We'll see how the adapter pattern, while it's rooted in software development, can offer valuable lessons for approaching any kind of challenge, really.
Absolutely.
We've covered a lot of ground, you know.
We have.
From square pegs and round holes to, like, project managers and translators.
It's true.
Who knew the adapter pattern could be so versatile?
It is pretty amazing how what seems like kind of a niche coding concept at first turns out to have these surprisingly wide applications.
But remember, I was really wanting to see some code examples.
Oh, yeah, you're eager to see
it in action.
I've got some bolts.
Yeah, to really bring it all together.
Okay, so let's dive into some actual code.
Okay, off in.
And see how this adapter pattern comes to life in different programming languages.
All right, let's do it.
So first, let's look at a simple example in Java.
Okay.
Imagine we have an interface called bird with a method fly.
Makes sense. Bird's got to fly.
Right. And then we have a class called sparrow that implements this interface so a sparrow can fly.
Gotcha.
Now, let's say we want to introduce this toy duck class that can also, quote unquote, fly, but it doesn't naturally fit that bird interface.
Right.
Maybe it has a squeak method instead of fly.
Okay, yeah, so there's that mismatch.
Yeah.
So how do we bridge that?
That's where our adapter comes in.
Okay.
We would create a toy duck adapter class that implements the bird interface.
Okay.
But internally, it holds an instance of that toy duck.
Okay.
So when fly is called on the adapter, it just calls squeak.
On the toy duck.
On the toy duck object.
So it's like behind the scenes, it's translating that fly call.
Yeah, the code that's using the bird interface doesn't even need to know.
It's not a real bird.
It's dealing with a toy.
That's pretty cool.
It is. And the beauty is if we later add other like flying toys with different methods, we can just create new adapters for them without changing that core bird interface or the code that's using it.
Right. Okay. I like that. So you've got that modularity, that flexibility. Now, is that how it works in other languages?
So the principles are the same.
Okay.
But the syntax might vary a bit.
Okay.
Let's take a quick look at Python.
Right.
So in Python, we might use duck typing and dynamic adaptation. So instead of like explicitly defining these interfaces, we just rely on objects having the methods we need.
So if it walks like a duck and quacks like a duck.
Exactly.
It's a duck, even if it's a toy duck.
Precisely. So our adapter in Python could just have that fly method that calls squeak on the toy duck.
Okay.
No need for separate interfaces or anything.
Python just makes it...
a bit more streamlined.
A little bit easier. Okay, that's cool.
Yeah, so each language has its own little quirks.
I'm seeing that, the nuances are becoming more clear.
Good.
So I guess the best way to really master this is just to practice, right? Like in different situations in different languages.
The more you experiment with it, the more intuitive it becomes.
But it's not just about like, the technical side of it.
Right.
It's about recognizing that underlying principle, right?
Yeah, like we were talking about before.
Of adapting to bridge differences.
It's everywhere,
Yeah, you see it everywhere, not just in code.
Not just in code.
So I was thinking about our examples with like the project managers.
Yes.
And the translators. And it really is amazing how this pattern can apply to like human interactions just as well.
I know, like a skilled project manager.
Yeah.
They adapt their communication style to each team member.
Right.
Making sure that everyone feels heard and understood.
It's about making those connections, right?
Exactly. And just like in software.
Yeah.
Those connections can lead to like greater flexibility, efficiency, even innovation.
Totally. Well, I think, for everyone listening, we encourage you to look for those adapter moments in your own work and in your own life.
Yeah, where can you bridge those differences? Yeah.
Make things communicate better.
Facilitate that communication.
Yeah, and create those valuable connections.
I think that's a great takeaway.
It is.
So keep those questions in mind, and we'll catch you on our next deep dive.
Sounds good.